Hi, everyone. Thank you for joining us today. This is an Asset Management Ontario sponsored webinar with SLBC, from Insights to Uptime, How Smarter Data Transforms Maintenance Programs. So we are joined today by Aman Singh, Senior Partner with SLBC, who's going to be your presenter today. I'll hand it over to Aman in just a moment. First, I'd like to start with a land acknowledgement. While I recognize that we're meeting virtually, I'm in Toronto, which is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabeg, the Chippewa, Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nation, Inuit, and Métis peoples. I also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. We recognize the enduring presence of Indigenous peoples and their deep connections to this land across the province and across Canada, and we're committed to reconciliation. So a few housekeeping notes. You'll notice that you're all on mute. We're going to be doing a Q&A at the end of the webinar. We will take your questions in the chat box. So do feel free to be engaging there, introduce yourselves, and pose your questions, which I will then read at the end of the presentation. And yeah, I think going to be a great session today. So thank you very much for joining us. And with that, I will hand it over to Aman. So Aman, please take it away.
Great, thanks, Jennifer. Good afternoon. My name is Aman Singh with SLBC, and thank you for taking time to join our webinar today. So today we're going to talk about maintenance as a formal program. And the goal of this session is to help you understand how to start developing a maintenance program, things like what needs to be in place, what to focus on first, and then we'll sort of close off with how data supports better decisions. So we're not going to focus on getting things perfect, but rather practical steps to move from reactive work to more planned, reliable maintenance. So we're going to focus on what you can do realistically to start building a formal program using the systems and people you have today. So we're not going to solve everything in an hour, but at the end of this session, I'm hoping that you leave knowing where to start and sort of what will make a difference to move the dial within your own maintenance program. So we'll start with the value proposition of having a formal maintenance program in place first. Then we'll move on to developing the program, and then following that, we'll close off with some sort of perspectives on data and how to start building up that program. So I'm going to start with this service delivery model. It's read from left to right. And if you've ever developed an asset management plan before, you'll be familiar with this. But essentially what this model just says is that if we look at an asset management program or a service delivery model, corporate and legislative requirements inform service levels related to capacity. Do we have enough of our assets? Function. Are assets meeting regulatory requirements? And reliability. Are our assets in a state of good repair? And then the model essentially says that as we move from left to right, operational maintenance, renewal, upgrade, and capital lifecycle interventions are undertaken to meet these levels of services. So the key thing that I wanted to sort of highlight here is that maintenance and the maintenance program does play a key role in the delivery of services, primarily by ensuring that assets are reliable, so they're in a state of good repair, and from an affordability perspective, because there is cost efficiencies that can be realized from maintaining assets in a state of good repair. So these cost efficiencies come to bear in the form of reduced energy consumption, deferred renewals, deferred capital, etc. And so your full asset management program is delivering levels of services related to capacity, function, reliability. Your maintenance program is the program that delivers all levels of services related to asset reliability. And so when we talk about maintenance, in most organizations, it's seen as a cost that needs to be controlled. But a good maintenance program does two things at the same time. It increases value, and then it decreases expenses. So first, maintenance increases value by improving availability. So when assets are available and reliable, operations can meet demand without things like workaround, overtime, or emergency breakdowns and fixes. Maintenance also helps maintain or even increase capacity without adding new assets. So if equipment is running reliably, you can often meet your current service level objectives as well as some growth with the assets you already have and not having to invest in additional assets because you're using the full capacity of your existing assets because they're not consistently down. At the same time, these lead to asset efficiency improvements. So your assets are lasting longer, they're performing better, and you have less failures. On the expense side, on the cost side, effective maintenance reduces overall spend. So even though your maintenance activities may increase. So in well-run maintenance programs, labor costs drop because work becomes planned instead of rushed or overtime driven. Material costs come down because failures are prevented and parts aren't replaced prematurely. Contracting costs are stabilized because you're not doing a lot of emergency callouts and paying for premium rates. And energy costs are improved, right? Because poorly maintained equipment just consumes more energy or power, even if they haven't failed. I'm going to just also close this section just with some maintenance trivia or some benefits of investing in a maintenance management program as well. So one of the simplest ways to understand maintenance performance is something called wrench time. And wrench time is the portion of the day where your crews or technicians are doing hands-on maintenance work. And in many organizations, this runs from 2 to 4 hours in an 8-hour shift. So 25 to 50% on the high end is how much time your maintenance staff are actually doing maintenance work. So this doesn't mean people aren't working. It just means that there's a lot of time being wasted, right? Time being wasted waiting for parts or inventory. Time being wasted because there's unclear job scopes. There's poor scheduling. You're searching for information. You're traveling excessively across the organization, or you're responding to breakdowns. So the important point here is that low wrench time is not a people problem. It's a planning and systems problem. And when work isn't planned, your technicians and crews start work without everything they need. They get pulled away mid-task to go get parts, work gets restarted, jobs are delayed, and generally this typically results in overtime, higher costs, and you don't get any better sort of outcomes. And so improving wrench time with your existing staff going from 2 hours to 4 hours to 6 hours means that you're actually increasing your maintenance capacity by 50, 70%, even without adding more staff. So on average, unplanned maintenance costs about 5 times more than planned work, right? So you probably heard these stats at different conferences or in sort of different areas. The reason planned work costs so much more, the reason unplanned work costs so much more is because there's a lot of costs associated with unplanned work. And planned work isn't less costly because it's cheap. It's just that when you have unplanned work, you have costs stacking up related to overtime, premiums for rush parts, time to collect information, putting in temporary fixes, and then getting repeat failures. So, I mean, that's the reason why unplanned work often costs 4 to 5 times more than planned work. And so shifting from unplanned work to planned work has a big impact on the total cost of your program. It's counterintuitive because many organizations, as their maintenance costs are getting higher, they try to control the cost by cutting maintenance budgets. But when planned work is reduced, unplanned work increases, and it's more costly to operate that way. And then, just some other cost signals to look out for that you'll see in maintenance programs that are sort of operating informally. One of the clearest is overtime. It's easy to track. Maintenance overtime often averages 14-15% in reactive environments, compared to less than 5% in organizations with formal programs. Again, high overtime isn't usually a staffing issue, it's a planning issue. We also see overall cost reductions of about 12 to 20% when organizations shift from reactive to planned maintenance. This comes to bear through fewer emergencies, less rework, and better use of labor and materials. Energy is another hidden opportunity. We often see organizations investing in energy efficiency, but with your existing assets, properly maintained assets typically deliver 5 to 20% in energy savings, simply by operating in the environment and the context that they were designed to, by being maintained well and having maintenance done when it needs to be done. And finally, inventory. This is low-hanging fruit as well. Inventory carrying costs often run 30% of the inventory value. And so if you had $1 million of inventory, the carrying cost of that inventory could be anywhere from $200,000 to $300,000 in terms of space, people, time value of money. So without a clear parts strategy, inventory is tying up cash, but it's not doing anything. It's not reducing failures. It's not preventing downtime. It's just sitting there on a shelf. Okay, so the summary of key issues, when we step back, the challenges that we've just talked about in informal maintenance management programs generally come down to two things. How is work planned and how is data used? So on the planning side, many organizations don't have dedicated resources focused on maintenance planning. And if that's the case, what you're going to have typically is supervisors who are doing planning on the fly. They're also managing people and responding to breakdowns, right? On the data side, backlogs are often not tracked in a consistent way or standard way, making it hard to understand how much work we have, what priorities, how much risk are we sort of taking on by deferring work or not responding to it in a timely manner. The other sort of data piece that's not really intuitive as well is that if you don't use your data well, your preventive maintenance programs become static. And what I mean by that is that if you're not updating preventive maintenance work based on asset history, failures, and condition information, which you would discern from good data, you'll just keep getting the same problems repeating over and over again, right? So those are the sort of the two key themes that we're going to focus on. Two of the, I would say, the key pillars that would be good to look at in your own maintenance programs to start moving the dial from reactive to proactive and start seeing some efficiencies in cost management, risk management, and performance management. Okay, so let's talk a little bit, sort of switch gears on, so if we were to build a strategic maintenance management program, a formal program, what are some of the artifacts that we want in place? What are some of the steps we would take? And how would we go about sort of building that program? What would be the appropriate steps to do? So a maintenance management program, like any program within your organization, has to sort of align with the strategic plan, right? So any strategy, you should only have one strategy for any organization. And everything else that you do in that organization, maintenance, capital planning, finance, human resources, having IT departments and all that sort of stuff, is an activity or a task that's meant to serve that overall strategy. And maintenance is no different, right? So the idea is that your strategic plan for your organization or your division or your service area sort of sets the long-term direction, right? It talks about the service levels you're delivering, growth expectations. Typically, it'll talk about risk and sort of financial constraints as well. And your maintenance program needs to have a clear line of sight back to that plan. So maintenance shouldn't be seen as a standalone activity because it is a key enabler of your asset management program and policy, like we saw in that service delivery model, right? Maintenance delivers all service level objectives related to asset reliability. So typically, in order to establish that alignment, you would have some governance in place, like a maintenance management policy, a policy that defines the vision for the maintenance program, goals, guiding principles, performance measures, as well as clear roles and responsibilities needed to support the strategic plan. And then once that's in place, we would develop your maintenance management strategy or roadmap, right? And the roadmap essentially is just like an asset management maturity assessment or roadmap, it's laying out the key initiatives, processes, and planning activities that you need to put in place to improve the maturity of your maintenance program over time, right? So what this does is that it allows the organization to move forward in a structured and achievable way rather than reacting to issues like we need to collect data, so let's go buy a CMMS. We need to do planning better, so let's put in a planner, right? So you have a more structured way of building up the maintenance program. Okay, so I wanted to introduce the Global Forum for Maintenance and Asset Management Framework. Essentially, this is a framework to develop a maintenance program, just like you would use a framework to develop your asset management program. Like most frameworks, it's aligned to the plan, do, check, act philosophy of most strategic frameworks. And it has sort of these 9 focus areas, which I'm going to go through over the next few slides. So essentially what the framework says is that if you have these elements of focus areas or elements in place in your maintenance management program, you'll realize the value of improved performance, risk management, and cost. And when you start thinking about and talking about the maintenance program, don't talk about it as a function that fixes things when they break, but rather as a program that supports improved performance, risk management, and cost management within the organization. So in terms of performance, a maintenance management program will help manage performance by, if you have a good program, you're reducing the likelihood of asset failures. If your assets are failing less often, you're providing improved availability, reliability of your assets. They're in a state of good repair, and you can deliver services through your assets. In terms of risk, a maintenance management program helps manage risk management, again, by reducing the likelihood of asset failures. If your assets are not failing as often, you have less exposure to the consequences of those failures. So less exposure to health and safety consequences, environmental impacts, financial impacts, service level impacts, reputational impacts. And a maintenance management program helps reduce cost by all the things we talked about during the value proposition piece, but primarily by extending the asset useful life and essentially by delaying the need for reinvestment in capital renewal, right? And there's other cost efficiencies that come to bear as well, right? So if your assets, again, are reliable, reduces unplanned breakdowns, which is a 5-to-1 cost of doing it planned, reduces the need for investment in additional redundancy in your systems. And then the big one, again, it reduces the need for spares inventory, right? Where you have the 30% sort of carrying cost burden on the program. So before we get into the 9 areas, just like you're developing an asset management program or a financial program or a project management program, you would do the maintenance program the same way, right? So if you're looking at a target operating model for your maintenance program, which is what is our strategy, what does governance look like, what do processes look like, what do systems look like, and what does data look like, you would do it the same way you would do it for any program, right? Start with the strategy. This means understanding your current state, current level of maturity, and defining a future state. So you typically can do this by assessing maturity against a framework like the GFM-AM or equivalent. This gives us an objective way to understand where we are today and where we want to go. Okay, so the gap between those two, where we are today and where we want to go, is going to be filled in with governance, process, systems, and data. So once the strategy is clear, we then put in things like governance, clearly defined maintenance processes, good roles and responsibilities. Then we go and we focus on systems. So a maintenance management system or other tools are there to automate processes, right? Not to be the process itself. And finally, data. Data comes last because it's the output of your process. Similarly, with most programs, organizations tend to do this backwards. They start with systems or data, and then they sort of move their way up the target operating model, which is possible. It's just much more inefficient to do it that way. And then it takes a lot more time for you to have a return on investment in terms of value through investments you're making if you do it opposite. Okay, so over the next sort of few slides, I'm going to walk you through the 9 key elements of the GFMAM focus areas, which sort of represents the core elements of what you need in your maintenance program, right? And sort of what you see here as the bullet points under each of those 9 areas are sort of practices that you can use in your own organization to benchmark your current maturity against. And for each area or focus area, I'll briefly explain what it covers. Where relevant, I have a sample KPI that you can use to measure progress. And so the intent isn't to do all of these things at once, but it's really to give you a practical reference that you can apply internally within your own maintenance program to start identifying some improvement opportunities, and then sort of filling in governance, process, technology, and data to close that gap and improve maturity. So the first focus area is business requirements. And this focus area is about setting clear expectations for maintenance. So in order to put a check mark against this, it's about having in place things like a maintenance policy that explains why maintenance matters within your organization. It'll explain how decisions are made and sort of who's accountable and who's doing what. In this focus area, we also look at maintenance being referenced in organizational plans, like the strategic plan, asset management plan, your long-term financial plan, right? So it's aligned with service level delivery, risks, and budgets. And this can be as simple as making sure that your asset management plans have KPIs in the levels of service section related to asset reliability or where you're spending maintenance and operational dollars. Those are linked to KPIs or service level objectives related to maintenance. And finally, you should have a set or a small set of KPIs that show whether the maintenance program is actually delivering results. Just like we do for capacity and growth, we have measures for greenhouse gas emissions and compliance and where we're spending operating dollars. You should have measures that tell us whether or not the maintenance program is delivering what it needs to deliver. The second focus area is asset creation. So this focus area is really about setting assets up properly from the start. So this means including maintenance and maintenance costs when you're doing capital planning. When we're looking at different options for renewal upgrades or capital works, it's understanding what the maintenance costs are going to be for each of those capital works that we're doing, right? Not just focusing on the upfront capital cost. This also means getting input from maintenance during design, so assets are reliable and practical to maintain. So there's some stats out there that say by the time you're finished design, 80 to 85% of your maintenance costs are fixed for the duration of the asset's life, right? So having maintenance provide input on improving reliability of the asset, standardizing parts, making them easy to maintain, designing out reliability issues that can come to bear when the asset's sort of commissioned. Once you pass the design phase, you can't go back and recoup those costs. They're fixed. And at handover, sort of this focus area looks at having all assets, pushed into your register, maintenance management manuals and data loaded up into your maintenance management system, so that when the asset's commissioned on day one, everything's ready to roll and there's no gaps that operations and maintenance are trying to fill in as the assets are being commissioned. The third focus area is maintenance tactics and types. And this focus area is about choosing the right maintenance for different assets, right? So not all of your assets need the same approach. Some assets can be run to failure, while others need preventative maintenance, and some might need condition-based maintenance. Generally, the choice is based on asset criticality, the impact of failure, and cost to maintain it. Most organizations will start with the OEM manuals and then sort of adjust up sort of condition-based or run-to-failure strategies from that baseline. And finally, the last part of this focus area is about having clear maintenance tactics help teams focus sort of effort where you're reducing risk and cost. So in other words, we're not applying the same level of maintenance effort on every single asset. The more critical assets get more effort, the less critical assets get less of our maintenance effort and resources. The fourth sort of focus area is maintenance strategy development, right? So this is about turning the maintenance tactics that we just talked about into a clear plan, right? And so this focus area is looking at defining at the asset level what work gets done, how often it gets done, and sort of what's going to trigger the work, right? So is it going to come from an inspection? Is it going to come from time-based tasks or condition checks? Again, strategies typically are targeted based on asset criticality or how assets are failing within the organization. But what I mean by that is you might have a preventive maintenance program and you're finding excessive failures on certain assets. And so you might adjust that program to be a different PM program, different frequency, or maybe you're doing some more condition-based monitoring to catch that failure ahead of time. The fourth focus area is human and material resource management. So this part really gets overlooked in the maintenance program, right? So it's about having a formal program to ensure we have the right people, parts, and resources to do maintenance properly, right? So having clear roles and responsibilities, tracking skills, making sure we have a robust training program for our staff, and then also having a succession plan so that we have an actual maintenance program. It also means managing spare parts, again, based on things like asset criticality, not just kind of what we've been always stacking based on bills of materials. And so the idea for this focus area is that if we have good resources, work's going to get done safely, it's going to get done efficiently because parts are always at hand, and we're going to have fewer delays. The sixth focus area is maintenance work management. So this is what everyone's probably familiar with. The focus of this is how work is planned, scheduled, and executed. It includes having in place clear job plans, realistic schedules, how long jobs take place, and a prioritized backlog, right? Understanding how work is prioritized as the backlog is building up. So the goal is to make sure here that our maintenance staff or technicians start with the right information, parts, and time, right? And a byproduct of having this in place, as we discussed earlier, is increased wrench time and reduced emergency work. The next focus area is asset performance and condition. So this focus area is about understanding how assets are performing and what condition they're in. So it means sort of tracking basic performance measures like availability, failures, downtime, mean time between failures, And these are some of the measures that you might have in your levels of service framework, for example. It also includes inspections and condition checks to spot problems early, right? So before you have a major breakdown, we can use inspections and condition assessments or checks to understand degradation and catch failures before they happen. The next focus area is maintenance data and information management, and we're going to sort of spend the last part of our time talking about this. So this focus area is about having data that people can trust and use, right? So this is having a good asset hierarchy, good naming convention, understanding the attributes you need, so everyone is talking about the same things. This makes sure that this focus area makes sure that work orders, failure information, and inspection data are being captured consistently, usually in a maintenance management system. And then we can use that data and information to look for trends and how we can update the maintenance program. The next one is maintenance program management. So this focus area is about managing the ongoing program, right? So it's not a one-time improvement. We put in the CMMS, we're done. We put in a planner and scheduler, we're done. We develop a training plan and we're done, right? So this includes setting targets, just like you would with every other aspect of your asset portfolio, tracking performance, and then kind of looking back to see what's working well and what's not, and making adjustments accordingly. Just like we do with levels of services for service level objectives related to compliance and growth and other things, right? So when failures occur, the program should be updated so the same issues don't repeat. So this is how you sort of inherently just improve your maintenance program over time and not keeping it sort of static. And this is where data also plays a huge role in improving the maintenance program. And then the last focus area is maintenance value delivery, right? And so this means sort of being able to visibly show how investments in the maintenance program in things like training and systems and processes and people and initiatives are reducing cost, are improving risk, and improving performance. And again, this is as simple as just levels of service reporting. So this sort of focus area advocates having simple dashboards in place where you can help leadership or decision makers in the organization see the impact of their maintenance decisions, right? How investments are being used to improve the program, or how lack of investment is causing escalations in cost, risk, and performance, right? So if the value isn't visible, it's hard to sustain or to get investment. Okay. So now all of us, including me, have the same knowledge on the GFMAM. So let's sort of switch gears now to using data to improve the maintenance program. So up until this point, we've really been just talking about, frameworks, policies, processes, roles, the missing value in the maintenance program. So what I want to talk about now is sort of switching gears to data. And what I want to focus on is just the idea that when data is simple and it's trusted and it's consistent, it's going to help move the dial on a lot of the elements of your maintenance program. And I was kind of highlighting as we went through those 9 focus areas where maintenance data actually is the key pillar to improve maturity. So in this sort of last section, we're going to look at how to use data as a practical tool to support your maintenance program. We're not going to get into complicated things like data governance and data standards and processes, right? I want to just focus on what are some simple things that everybody can do today to start building better data that you can use to improve the maintenance program. Make better decisions on what work we do and when do we do it, okay? So I wanted to start with this diagram because I think it's quite telling in terms of where value sits in data and processes, and sort of how we tend to focus on sort of the smaller stuff versus the bigger stuff, right? So this diagram shows where sort of operational costs and improvement in maintenance come from, right? So about 60 to 70% of the benefit of your maintenance program is going to come from business processes, right? So how is the work planned? How is it prioritized? How is it executed? The other 20 to 30% is going to come from information management, having good data, having consistent data that people trust and can use to make decisions. And software and IT infrastructure makes up less than 5% of that value. And I wanted to show this because most organizations, again, remember I showed the target operating model, sort of focus on the bottom part of the pyramid with respect to investment. So there's a lot of money and attention that goes to software systems and technology enablers. But the real value comes from getting the top right first, because the software and IT infrastructure is just there to automate the top part of the pyramid, right? So if you don't have a good top part of the pyramid, you're just going to automate poor processes. So in other words, we're going to get more value for a maintenance program from having the right data, from having good processes, versus from having tier one technology systems that can capture the data and house it. Okay, so when we talk about maintenance data quality, we can focus on simple things. So 4 simple dimensions that you can start looking at today, and then obviously use those to sort of improve the quality of your maintenance data as well. So the first is completeness. This is really just focused on simple things like, do we have all of our assets in our system? Are work orders being closed with the information that we're asking for? So when our crews and our staff and our technicians are closing out work orders, are we getting information like what asset was worked on? Why was the work needed? What was found? What was done? How much time and cost did it take? And is there any follow-up information? The second is accuracy, right? So this has to do with, does the information reflect what happened in the field, right? So was the right failure cause selected? Were condition readings recorded correctly? The third would be consistency, right? Do the same problems get recorded the same way, whether it's by different crews, by different shifts, or by different organizations within our division or service area. And finally, usability, right? So can planners, supervisors trust this data and make decisions? And so these are simple dimensions where you can assess the data quality of your maintenance program tomorrow, right? And the idea would be that if you focus on these key pillars, you're going to have good base data quality that you can start making decisions off that will support all 9 of those focus areas, right? And so, for example, for completeness, checking to see if all the assets are in the system. Yes, if they're not, then that's a key focus area for you to make sure assets or processes are in place to make sure the hierarchy is getting updated when assets are being commissioned. Work orders and being closed out. You can spot check 10 work orders done in the last 12 months. Did you have the right information being collected? If not, those should be configured into your work order. And if people are not filling in those, then there's an opportunity to improve governance around closing out those work orders, right? So these are like 8 or 9 simple things that you can start doing to improve the quality of the maintenance data quality. So usually when it comes to maintenance data, we see some very common challenges. Again, these are sort of what we see across the board in a lot of organizations. A lot of information is captured in free text in work orders. you can't analyze it or trend it. So it's lost data. Failure codes are maybe available to be selected, but they're not used consistently or they're not used correctly. It's an opportunity for training and some governance on getting those right. Preventive maintenance can often stay static if you're not using data well. What I mean by that is someone goes in and looks at some PM. So you have a pump that keeps failing every quarter, but it stays on a quarterly PM. Someone just keeps fixing it, right? So using that data to do things like root cause analysis and making changes to the type of inspections being done or preventive maintenance. And then finally, inspections are typically being completed, but nothing changes as a result. So the purpose of an inspection is to drive action. So if inspections don't drive action, then essentially they're just a reporting exercise as opposed to being used as a reliability function. In order for an inspection to be used as a reliability tool, they need to be good inspections, so looking at the right things. They need to be done. They need to be consistently. They need to be filled out properly. And they need to be able to be trended and analyzed. So there has to be some digital component to allow people to look at the outcomes of the inspections, to turn that data into information and then knowledge that you can then act on. Okay, so here's another simple model that shows sort of where you can start to progress the maturity of your maintenance data, okay? And I'll sort of talk about how each of these 4 sort of stages are characterized. So if you're starting sort of in a reactive state, this usually means that you have limited data and you're spending a lot of your time on fixing things, and you might be tracking costs at a very high level. So if you're there and you want to move to a more controlled state, you need to start standardizing some of the basics again, right? Your asset registers, your PMs, your failure codes, your backlog tracking. From control to proactive, essentially what this is saying is this is kind of shifting from just having data within the organization to now using it to find patterns or spot trends. When you find patterns and trends of things that don't look right, you can now adjust the maintenance program to say we need a different PM here or a different frequency. And the litmus test of if that's working is you should have fewer failures going forward. And then as you're moving from from proactive to predictive or optimized, this is where you're using reliability data, really focused on good processes and continuous learning. Very similar to the proactive stage, it's just that you're using more tools like condition-based monitoring versus just inspections, right? And so every level sort of builds on the one before it. And the maturity is characterized by what you're able to do with the data, the type and quality of decisions you're able to make, right? So moving from just putting out fires on the reactive side to then looking at the data, turning it into information and knowledge on the proactive side. And then on the predictive and optimized side is really using that feedback loop to tighten up your program. What's run to failure? Do we have all the PMs in place? Are the frequencies optimized? Do we have the right type of work? And then on what set of assets are we going to do sort of more work in terms of trying to catch degradations before they happen? Again, condition-based or predictive techniques. So the practical improvement pathway. So all these slides, there's never going to be more than 4 bullet points. So I wanted it to be kind of basic and easy to start, but also meaningful in moving the dial on how you're making decisions and the value you're getting for risk management, cost management, and performance management. So this slide shows simple steps you can take to improve maintenance data without overcomplicating things, right? Again, we start with this philosophy to standardize basics. Again, you've heard me say this 5 times now. Put in place a good asset hierarchy, consistent naming conventions, get our failure codes in place, so everyone's recording the same thing the same way. The reason this is important is if someone goes in and puts, I worked on pump number, and they put the building name and the floor number or something else, and then someone else works on that same pump, but they record it as a different pump, like pump number 6, you're never going to get all the data against that same asset because it's sitting under different names, right? So you can't trend and analyze that data and information properly. Then next, make the data useful, right? Have clear job plans, have realistic durations for how long it takes to do that work, and consistent inspections. So you have a good volume of data to make trends and sort of analyze and look for patterns within the data that's coming back. And then closing the loop, adjusting PMs, frequencies, and forms based on what you're seeing. So I read recently of a large utility that they had a fuse blow, and the fuse blew out, caused a major interruption in their operations. And they simply said, oh, how did that happen? No one's inspecting our fuses, so they added an inspection and a way to check if the fuses were okay. And now they're tracking those fuses going forward, so they don't have that failure going, a surprise failure again, right? Even though it's a fuse, it could be a critical failure because of power loss, or it's sort of causing very critical assets to go down, right? So it's that very simple feedback loop that's going to improve your maintenance program. And then finally, measure, right? We measure all elements of our asset management program, from financial to growth to compliance, but very little measurement around the maintenance program. So this is about tracking PM compliance, repeat failures, downtime where it's kind of excessive, and then making adjustments to the program to get those things down to where they need to be. And so again, the continuous improvement cycle, very simple again, right? We take a few minutes, look at the data, we find patterns, same assets failing again. That helps us get some insight onto what we're going to change, PM task or frequency. We update job plans and inspections, and over time, your performance should also improve. All of this is underpinned by having, few critical basic data attributes across your maintenance program, right? Collecting it, looking at it, adjusting, collecting it, looking at it, and adjusting. Okay, I wanted to touch just one slide on sort of predictive and condition-based, because I think a lot of organizations do it or are looking to do it, and sometimes before they have a basic PM program in place. So when it comes to predictive and condition-based maintenance, again, you can start small and uncomplicated, right? There's so much information and technology around AI, but this predictive maintenance isn't about rolling out sensors everywhere or buying new technology, right? It can start with the data that you already collect. So instead of having simple pass-fail inspections, you could adjust your current inspections to have meaningful indicators, like maybe you're on pumps, you're looking at vibration. Maybe on fuses, you're doing thermography and looking at temperature readings, right? You track those values over time. It'll help you understand where degradation is happening early, and then you can put in a corrective work so the asset doesn't fail prematurely, right? And so as you're building these inspections with these indicators, you're actually also understanding the threshold where work needs to be triggered from a condition perspective. So instead of doing something every 6 months, you might say we need to do this earlier or later based on how we're seeing the asset degrade, right? Putting this in place, if it's done well, it helps you eliminate low value preventive maintenance things like, this is a pass or a fail, reduces unnecessary inspections that don't actually provide any value, and it helps you focus your skilled labor and technicians on work that actually needs to get done. Okay, so I've got just 2 more slides left. The litmus test or the gut check for, do we have good data is 3 things. 1, the data is trusted. So people are confident in the assets and failures being recorded. They're making decisions and adjustments in the program based off that. Second, you have justified PMs. So tasks are based on history and condition, not just we've always done this every 3 months. And third, you have sort of action-oriented KPIs, right? So you have some measures that help you decide what to do next, not just to report on already happened. So you want some leading indicators on where we're going versus just reporting on lagging. We had 50 failures last month, or 300 work orders didn't get done in the last 6 months. Okay, in my last minute here, I wanted to talk a little bit about, selling the maintenance program for investment within the organization. And what we've done is we've just compiled some effective ways that organizations have gone about securing sort of business cases and dollars and resources to start the maintenance program, right? Because it's a hard sell when the maintenance program was not visibly showing or tracking improvements or efficiencies in the organization related to cost, performance, or risk. So the way to do this is lead with your business case. Connect maintenance improvements directly to things like reducing risk in the organization, controlling cost, and improving reliability or performance, right? There's not a strategic plan in any municipality that doesn't talk about those 3 things. Early on, focus on quick wins. You might show that we have reduced overtime. We're trending fewer emergencies. Backlog is getting stable. It's not uncontrollable. Get some simple dashboards that show before and after results of investments in the maintenance program. It's always good to kind of sell the program sort of in finance words as well. So think about life cycle cost, how much money is being deferred in capital because of good maintenance, how asset life is being extended, pushing out renewal costs. And keep in mind that every failure should improve your system. And your data, if it's reflecting failures properly, will allow you to improve the system in a very targeted way, in a strategic way. So this is how your maintenance program moves from being seen as a cost within the organization to being recognized as a strategic program. Okay, thank you for your time. With that, we've got about 8 minutes for questions, if there are any.
Excellent. Yeah, thank you so much. As promised, I think very, practical solutions for folks. So thank you for that. We do have a couple of questions already in the chat. And folks, you do have a couple more minutes here if you want to type more. So first question from Sherry Young. Where do you factor in considerations about the impacts of climate hazards on expected useful life of an asset?
Well, climate hazards is just one type of risk that impacts your assets, right? And you can address that through maintenance, you can address it through renewal, or you can address it through capital work. One thing that I do know where it gets addressed is that there is a framework, the FAO created a framework that essentially laid out maintenance costs and operational costs that you can use to benchmark if you weren't tracking climate and hazard costs related to climate change. And essentially what it showed was like a percentage, 10 or 15% additional maintenance and operational costs to address climate-related impacts related to things like cleaning, hazards out of the way, getting things up and running, emergency repairs, et cetera, et cetera. So just like you would look at upsizing an asset or doing a different renewal to make your asset more resilient against a climate impact, the same way you would account for the maintenance activities you would do to address them. I think my experience has been in the literature so far that maintenance and operations is usually addressing climate after it happened versus preventing it. Most of the resilience and prevention comes from, I think, capital and renewal in terms of what folks are doing today. I hope that answered your question.
Excellent, thank you. Another question from Sherry. Limiting text field entries in favor of consistent data is helpful for traditional asset management. How do you recommend including natural assets in traditional systems when many don't have the data fields built for that, and customization or program replacement can add significant cost barriers to including natural asset relevant attributes?
Yeah, I'm a huge proponent of having no data fields or limiting them and having drop-down menus where you can have standard input because it's faster and it's easier to analyze and trend. So whether you have a tree or a lake or a piece of pipe or a road, you should have a drop-down menu for reason for failure. And the difference in that menu is how that asset could fail. Whether you have a tree or a pipe or a shrub or something else, the symptom code of what went wrong, or like an electrical piece of equipment, should have a drop down. The only thing that's different is what are the symptom codes for that asset. Even condition, there's condition assessment approaches for things like trees and natural assets, just like there are for roads and pipes. So you should try to configure those in the drop-down menus, but just specific to the asset would be my recommendation.
Yeah, I'm with you. Natural assets, a topic very close to my heart, and our advice is always, yeah, make it you can adapt it to be comparable to your built assets. So there's no reason you can't integrate them in exactly the same way, and that's how you evaluate them appropriately, right? Um, okay, that is all we've got in the chat. I have a question for you as well, though. So, as I said, I think, as promised, oh, and Sherry says thank you in the chat. So I think you did answer her question well. So a lot of practical solutions that you walk through, and some good step-by-step instructions. So I wondered if we could sort of add a time element, thinking about that data maturity, the maintenance data maturity model for folks on that kind of left-hand side, the more reactive or controlled stage. What are, maybe one or two things that are going to have the biggest impact in the first, let's say, 6 to 12 months? If you had to sort of say like low-hanging fruit, where are people going to see the most kind of return on their efforts?
Yeah, just what it says here. So a lot of the data and information that you're going to look for is where do we have patterns or trends of failures that don't make sense? They're happening too fast. In order to do that, you need to understand how the asset's failing, right? So things like basic failure codes. This pump failed because of an impeller wear out, or this pump failed because of an electrical issue, right? There's a cadence by which how often an impeller should wear out. And if it's wearing out faster, that's where you can go in and adjust if you're catching it in terms of your inspection, or if you need to do something else other than just replacing the impeller every time, because maybe it's a vibration issue, right? And so you might have to start looking at that as part of your inspection program. And then standard PMs, right? So as I mentioned, a baseline way to start all your PMs is what's recommended by the manufacturer, and then adjust to less work, like run to failure because the asset isn't critical, or more, a higher frequency, an additional PM, or predictive work on top, right? And you're just scaling that based on, if I just started with the PMs that the manufacturer told me to do, and then adjusting the ones based on the data that's telling me what we're doing here is not good enough, right? Because we're having premature failures or surprise failures. And sorry, I'd add one more thing. The most basic thing is to make sure all the assets are in the hierarchy and they have PMs. The very first step, and I think it came across on 6 of the 10 slides.
Perfect. Okay, we are at 1 o'clock, but we did get one more question in the chat. Do you have time to squeeze in one more response?
Yeah, of course.
All right. Final question, and I understand some of you will have to drop off. Thank you very much for being here with us. We will share the recording with you as well as the slides afterwards. So final question. There are always emergencies, even with proactive maintenance. How do we ensure that we have enough budget for it and staff to perform that task without paying overtime or lacking budget?
Yeah, so the maintenance program is a program. It never ends. It's always continually improved. You're never going to get a perfect program. I think the way to get investment is to show the benefit of doing that additional work, having additional crew versus paying for overtime. But you have to sell it to the leadership, right? We need more maintenance staff, or we need better systems, or we need to invest in more preventive maintenance programs and stuff like that, right? And the only way to do that is based on talking with organizations that are approving or disapproving maintenance costs. Is it's kind of show me the money. Show me that when I give you $1, there's a return on investment on that dollar. Something's getting improved, risk, cost, or performance.
Excellent. All right. Thank you again. So that's all our time today. Amon, I really appreciate you being here with us. And again, great presentation. Thanks to everybody who joined. And as I mentioned in the chat, we will be sharing slides as well as the recording and a brief survey that I'm hoping that you will all be willing to complete. I'm going to throw that survey link in the chat right now. You'll also get that in your email. So thanks again, and everyone enjoy the rest of your day.
Thanks, everyone. Have a good day. Bye.